Hi students, this is your Unit 3 test review. Remember, you're supposed to be doing this on the back of your take-home quiz, so make sure you found your take-home quiz and you've completed your take-home quiz. There will not be time to work on that take-home quiz in class on Tuesday when we come back to take this test. Remember, on this test day, 1021, we have our district checkpoint and our Unit 3 test. So we're going to go ahead and knock out both of those things in one class, and that way we're not testing over 2 separate days. Alright, you're going to put this on the back of that. All you're going to do is work the problems that I do in here and write down any questions that I do. Alright, so one of the first things we learned about once we got into the 6 weeks was how to solve a single variable inequality. This has x's in it. We used a lot of the same strategies that we used when we were doing equations. We always want to move the x's to the left. So we start out, we look for simplification on the left-hand side, so we look over here on the left and on the right for simplification. There's no simplification that needs to be done, so then we start moving our x's. So a positive 5x, we subtract 5x. We line it up underneath the 3x because those are like terms. So 3 minus 5x is negative 2x. Bring down the negative 2, bring down the symbol, those cancel, bring down the 14. Now we're going into a simple, just regular solving. Minus 2 gets a plus 2. Those cancel, bring down the negative 2x, bring down your symbol. 14 plus 2 is 16. And the last step, when it's beside it, we divide it. So we divide both sides by negative 2. The negative 2's cancel and we get x. 16 divided by negative 2 is negative 8. Anytime we divide by a negative, you must flip. So we flip our symbol to be greater than or equal to negative 2. So we go to negative 8 and we're going to put a dot. Because it has a line underneath it, we have to color that dot in. And remember that inequality face that we did, that'll help you figure that out. And then this arrow points to the right, so we draw our arrow to the right. Remember, inequality face looked like this. And then his evil twin brother looked like this. Alright, next problem. Here we're supposed to find the domain and the range. I think it's in your best interest to write all of the ordered pairs. So this ordered pair is over negative 6 up 2. So negative 6, 2. This one is over negative 5 up 7. This one is over negative 2 up 4. This one is right 1 down 2. This one is over 3 up 7. I'm going to do my domains in red. My domains are always my x's, so that's all these numbers right here. So I list them in numerical order, negative, and because I went from left to right, these are already going to be in order: negative 6, negative 5, negative 2, 1, and 3. I'm going to do my ranges in blue. My ranges are this side. These will not be in order because I did not go from bottom to top. So negative 2 is the smallest. Use that one. Then regular 2. Then 4. And then 7. And I only have 4 numbers because these two right here share the same. They share 7 together. I think it's in your best interest to write the ordered pairs every time that we do this. Alright, and this is where we set up the ranges. We're going to do domain and range again. But you set up your boundaries. This one is $, the robot. This goes all the way there. So that crosses that number. And all the way there, that crosses that number. So this crosses at negative 6 and positive 3. Domain is always x. We always start with less thans. And then we check the symbol out. An open one stays less than. A closed one gets a line underneath it. I'll switch over to range. Range goes bottom to top. So be careful. I saw a lot of you on your quiz. You weren't drawing your line there. You were drawing it up here. And that's not right. You can't have this part of your graph hanging out from under it. So do not do across there. Okay? You've got to draw it across where I drew it right there. That's the bottom of the graph. That crosses there. The top of the graph is way up here at the top. Okay? Your whole graph has to be contained in this rectangle that we drew. So this goes all the way down to that's -7, -8, -9, and all the way up to 7. Y's go in the middle, less thans, less thans. At -9, see how the curve touches the line? That gets a line in there. This open, so it stays like that. So this is your domain and range for that. That's a continuous function that gets the inequality treatment. Alright, the next type of problem we had, if you're trying to find what is the range, so what are the y's, when we give you this function and we give you x's. So we taught you to take that and plug it into your calculator. My cursor's flashing there so you can't see, but that was a -3x plus 4. We get to this by pushing the y equals button. Then we get the graph to come up, so we do second graph, sorry I said graph, it's a table, to get that to come up. In the meantime, we set up our own table. Since I was given x's, I'll fill out this side, -1, 0, 2. I check my calculator to see what goes with -1. I check my calculator to see what goes with 0. And I check my calculator to see what goes with +2. Okay? And so you can do it all in your calculator. The next one is the opposite of that. It says what are the x's using this function when the y's are that. So again, I go and I type in my function here. So we did y equals to get there. Then we did second graph to get the table. The difference in this one is that this time I was given y's, so the -2, 0, and 13 go over here. So now I'm looking at this side and I'm writing down this side. So I go find -2, it's right there. 7 went with it. I go find 0, 5 goes with it. I don't see 13 on my graph, so I could scroll up on my graph. Let me scroll. 13 goes with -8, so I had to scroll way up on this side to get to there. Alright, some other things that might be covered: correlation. If it is slanting up, it's positive. Slanting up, it's negative. Scattered, it's no. Don't forget about when you're solving equations to double rainbow. That would be happening first here. So that's -2x plus 12 and 3x plus 2. Then we want to move the that's -2. So we want to move that by adding 2x to both sides. That becomes 5x plus 2 equals 12. Subtract 2, subtract 2. Those cancel. 5x equals 10. Divide by 5, divide by 5, and x equals 2. Okay. This is a picture pattern. It wants to know in each term in the sequence how many boxes are there. So in picture 1, there's 1 box. In picture 2, there are 2 boxes. In picture 3, there are 3 boxes. Okay? So if it doesn't give you these numbers, you have to fill them in yourself. Then if we want a rule, like say we want to find out how many are in the 50th, okay, then we want to create a rule. We do that by doing stat edit. So you push stat 1, brings up a blank table. In that blank table, we put in the table we made, 1, 2, 3, 1, 2, 3. Then we push stat again, right arrow down to number 4, and we get our expression. And our expression in this case is y equals x plus nothing. So if I wanted the 50th, I would plug in 50 there. Y equals 50, so the 50th term has 50 boxes. And it makes sense. You can see 1 is 1, 2 is 2, 3 is 3, so 50 is going to be 50 in this case. It won't always work out that way. But that is your review. Make sure that you bring it and your take-home quiz completed back to class on Tuesday.